On the Radar with the CBS 17 Storm Team.
Welcome back to On the Radar. Meteorologist Ross Whitley with you here, as well as Rachel Dunsing. So another fantastic Ross and Rachel episode. And this week we're making zero promises on staying on time.
We have learned our lesson.
We have. I think we're 0 for 4.
Yeah, which means we haven't learned our lesson.
We have the gift of gab. We like
That's why we're in this business.
We like to talk, and hopefully you like to listen to us talk, and that way we get to keep our jobs.
Yeah, fortunately we have a lot to talk about today.
We do.
We have a nice little segue there, so we're going to go back and talk a little bit more about space weather just because it's such a fascinating topic. We're going to talk about the current solar cycle that we are in, how it compares to some of the other solar cycles. Everyone, of course, has been talking about La Nina, El Nino, ENSO, neutral. What is it? What is it going to bring for us for winter? Is it going to have an impact on potential snow? We'll have more on that. Talk about, I think, Ross's favorite topic.
Yeah, absolutely.
The polar vortex. And also a little something called polar night.
If you ever want to get under my skin, you can bring up the polar vortex and talk about how it's visiting the lower 48. And I promise I will go off on you. The polar vortex does not exist at the surface. We're going to get there. We're already getting on my soapbox.
It's also always around, even in the middle of summer.
Yes, it is. It's also all the way around. And there's a reason it's called the polar vortex, because it exists at the pole. But again, we're going to get into all of that, the buzzwords and the feeds. This is going to be a new segment called Ross's Rants. I'm just kidding. But yeah, that is definitely
Honestly,
up
we
there.
should do it.
That's definitely up there on Ross's Rants.
I've heard a few of Ross's rants already,
Yeah.
and we could have an entire show devoted to each one.
Yeah, but I don't think we should spare the people of my opinions.
This is probably true.
I don't think they want to hear it. Let's start off with the solar cycle. And this is something that, honestly, I haven't been super aware of until as of late. And I think a lot of that has to do with the activity we've seen as of late and how this has come into the mainstream.
Yeah, and this is something we talked about last week, too, with the aurora and all of that, is these solar cycles, these solar maximums, they vary, from, 20-something years is typically when we have it. So, and you can see there, we had one very active one, roughly around 1980. About a decade later, we had a solar maximum, again, roughly 10 years later. So they're saying anywhere from 11 years, sometimes it can be 20, but most of the time, 10 years or so. And you can see there was one sort of around 2011, 2014. It was much less active than the previous solar cycles. And so that's probably part of the reason why this solar cycle that we are dealing with, solar cycle 25, seems so active. Now, don't get me wrong, it is incredibly active. A lot of them have been saying this, especially if you compare it with the graphic, the most active solar cycle in the past 20 years. And just look at that data. It doesn't seem like it's quite as active as the 2000-2001 solar cycle, but definitely verifies the fact that it's at least the most active within the past 20 years or so. So this is what we mean when we're talking about an active solar cycle. You can kind of see it on the graphic there. So remember, the sun is a really active star. We don't think about the sun as an active star all the time just because it's kind of up there doing its thing and we don't think about it until it starts to explode is probably a bad word, but until it starts getting really, really active. And so you can see just the differences there with the solar minimum. It just kind of looks like how we would normally expect any sort of satellite view of the sun. And then with the maximum, you see these sort of curls and these sort of explosions coming off of the sun. That is when it's in more of an active phase. Again, we get those CMEs, we get some flares, they come off the sun, we get all of that energy, all of the magnetized particles and the plasma coming off the sun and headed toward Earth. And that is what we have been dealing with here over the past few years, really.
Yeah, I agree. And I think this picture really encapsulates that very well, where you can see solar minimum, not a whole lot going on, solar maximum, just all kinds of crazy activity. Yeah. And I love these X-ray shots of the sun where you can see them in high definition. It's almost like whenever we've had total solar eclipse. Wow, that's a tongue twister. And you can actually see those corona mass ejections out on the outside of that eclipse. So there's some cool photos there. But it's been really neat. And the reason we've seen the solar activity, specifically the aurora, the northern lights, has been because we've gotten these waves to hit Earth and kind of peak when they were hitting Earth. And that only happens if we get to a certain magnitude. So for us, that is the KP index. And we have to have a KP7. We really want it to be G4 or G5, which is talking about the severity of the solar storm. And if you didn't watch last week, we talked about probably the biggest solar storm in recorded history, which was the Carrington event that happened back in the 1800s. Thankfully, not a whole lot of electricity back then, so it didn't impact a bunch of things. Whereas if that happened now, we would be talking about some pretty big impacts, like total blackout of a lot of stuff. So hopefully that doesn't happen anytime soon. But when we do get these KP7 events, they do allow us to see some pretty cool stuff. And we just saw this. And again, you might be past and over this. Yeah. We are not.
No, it's just the coolest thing.
It is. It's so cool.
And especially, this far south, this isn't something we typically get to experience. You see the webcams out of Alaska and Iceland and Canada and all of these places that see it pretty much, I don't want to say nightly, but basically nightly, especially during the winter. We don't get to see it that often. We definitely don't get to see it in the same way they do. So you see something like this where we have the KP8 with a strong G4 and you saw sort of the sky glow a little bit, even if it was only through your camera. Although I took a picture around the same time of this one that you took around Wendell. Yeah. And we were all communicating through text, the weather team was, and you said it about the same time I said it. I feel like I can see the sky glowing red.
Oh, absolutely. I could definitely see it with the naked eye that there was red hues going on. And with the camera, you could see it dancing around, which was just crazy.
Yeah, but it was faint. But we don't often get to see it, through our phones or with the naked eye. So it really just is a cool event. And how fortunate are we that we've been able to experience, 3 in the past year to year and a half?
Yeah.
Very, very cool for us.
Very, very cool. And something that is also very, very cool, which you've probably heard of, is the polar night. And that is when the sun disappears in the Arctic Circle. Now, that happens both in the northern and southern hemisphere. So we don't hear about it as much in the southern hemisphere, mainly because there's not a whole lot of people that live on Antarctica. But there's a lot of people that live north of the Arctic Circle in the northern hemisphere. People in Sweden, Norway, Russia, and then, of course, here in the U.S. and Alaska. And Matthew did a great explanation on exactly what that is, so we're going to let him take it away.
The phenomenon known as polar night kicked off this week in Utqiagvik, Alaska, formerly known as Barrow. The city is home to nearly 5,000 people and is the northernmost community in the United States, lying more than 300 miles north of the Arctic Circle. The sun set at 1:56 p.m. local time on Tuesday and will not be seen again until January 22nd, when it rises at 1:23 p.m. that day. That means for a stretch of 64 days, the sun will not be visible above the horizon, though there will be hours of twilight at times similar to dawn or dusk, and the northern lights also provide a source of light periodically. The reason for the lack of sunlight is due to the tilt of the Earth. This time of the year, the Earth is tilted far enough away from the sun that it never quite reaches extremely northern points. For areas above the Arctic Circle, this effect is even greater. As you can imagine, this has quite an impact on their weather. The average high for December drops to just -1 degree with an average low of -13. By January, those numbers dip even more to a high of -5 and a low of just -18. Thankfully, Raleigh never gets that cold, but our December averages are on the cooler side as well. 54 degrees on average in December with a low of 35, and by the start of the year, those numbers dip to 51 degrees for the high and 32 for the average low. Our amount of daylight never approaches Alaska numbers either. The earliest sunset for Raleigh comes on December 1st at 5 p.m. The least amount of daylight we'll see is 9 hours and 44 minutes on the winter solstice, December 21st. Much better than the zero they'll see in northern Alaska. So the next time you find yourself complaining about the early sunsets and lack of daylight, just remember it could always be much worse. I'm meteorologist Matthew Huddleston. Back to you in the CBS 17 digital studio.
Yeah, it could always be much worse.
I agree with him. That sounds terrible. I've
yeah.
experienced below zero just a handful of times, and none of those times did I enjoy being at below zero.
Absolutely
It's
not.
instant burn.
Yeah.
Everything's cold. There's no way to warm up. It's just pain. You don't even feel cold. It's just painful.
Yeah, it happened when I was in college. I went to college in Northwest Indiana, and it was when we had a big polar vortex.
Oh my
Kind of
gosh.
The big one that really blew up back when
This
the
is
internet.
2014?
It was.
This is when the toilet bowls froze in Chicago?
Not in Northwest Indiana, they didn't. But we had a wind chill of like -40, -45, something. So they canceled classes because, of course, they did. And, of course, college students still go out anyway. I had some things that I had to help with in the meteorology department. And so I'm walking from my apartment onto campus. I had a coat on. I had my scarf wrapped around my face. I like literally had this much. And my breath froze on my scarf.
Oh, absolutely.
It was like a 10-minute walk, and that was it. And then I get to the door that I needed to go into, and I put the key in, and the door was frozen shut. I'm like, why am I out here right now?
Yeah, that was
I could
your
have been in my
mistake.
apartment in my warm, comfy clothes
Yeah,
and watching
several
TV.
blankets on you. Yeah, that was totally your
Yeah,
mistake.
so I can't imagine having that with no daylight for 2 months straight.
No, me neither.
That's too much.
But we are talking the changing of the seasons, and with that comes the polar night, and with that comes winter weather outlooks, which Rachel and I have already talked about at least somewhat because we both like winter weather, or at least I like winter weather. I think Rachel might be indifferent.
I can take it or leave it.
I grew up in North Carolina, okay? We only get it every,
That's true.
every now and then. You grew up in a little more Midwesterny climate.
I do like snow. I do. I just don't like having to
deal with
drive in it and deal with other people in it.
Nobody likes dealing with that.
That's
At least we get to have fun when it snows. We
This is
might
true.
work a little extra, but at least it's fun.
At least it's fun. Yeah.
For the most part. It's kind of fun. So speaking of that, let's go to some of the factors that are happening this year. And one of those is, will we have La Nina? Won't we have La Nina? Have we had La Nina? This summer, which really impacts hurricane season, La Nina was a big topic of discussion because it was like, oh, shear is going to be less over the Atlantic, and we're going to see more hurricanes because of that. Well, La Nina never really got a foothold on the atmosphere. We kind of got to what they call a Meduki, which means portions of the Pacific highlighted showed La Nina in full. Other areas of the Pacific did not. So you get these places that show La Nina presenting and other places that don't, which kind of leads you to be a little more neutral, which is exactly where we are right now. We are technically in La Nina, but will that continue? Well, it looks like it will likely continue through the winter. So that is going to have some impact on our winter weather setup. What does that mean whenever we have winters with La Nina? Well, typically, we're talking about warmer southern half temperatures. So if you look at the lower 48, which we're getting ready to show you, we'll see that southern portion of the lower 48 be warmer than average. Now keep that in mind. It is warmer than the average. And our average high in January, as Matthew just highlighted, is in the 50s.
Yeah.
So if we're 57, we're warmer than the average. We're warmer than where we should be at 55. So sometimes that can be a little deceiving when people are like, oh, we're going to be warm. It's like, no, that's not what we're saying.
Yes, but.
Yeah. And typically, we usually get big dips in the jet stream from La Nina, and specifically across the central and eastern portions of the U.S. So what does that mean for us? Well, that means typically we get bouts of cold. Even in a warmer than average winter, we usually see shots of some really big cold because it kind of gets all stuffed up into the north, and then every now and then it breaks free and comes down into the southeast. And so we don't see these long stretches of cold typically, but we do get these bouts of colds, and that looks likely as far as our winter setup is going. So What does that look like as far as looking at a specific graphic? Well, as we're showing you here, the trade winds push that warm water further off to the west. We see colder water develop or upwell in that equatorial region, and that's how La Nina is established. And what does that do to the jet stream specifically, Rachel?
Makes it more variable.
It makes it more variable. And typically what that does is we'll see a higher ridge in the west. Now, you can kind of use your brain power here and think about if that ridge ends up being over the Pacific as opposed to the Pacific Northwest, then that dip could be a little more central and favor possibly a wetter pattern and more active pattern at times across the Carolinas and the East Coast. So the dip kind of slides to the west. You see that wet area slide to the west as well, and then that could put us more in that favorable setup. So it kind of wavers and goes up and down, waffles, if you will. We're using all the W's here.
I always say wobble, but yeah.
Wobble,
Yeah.
wobble, waffle, wafer, all of it. I watched a holiday baking thing the other
tell.
day, so my brain is on all the pastries.
Yum.
I mean, why not? And that's exactly what we're seeing as far as our winter setup goes.
Yeah, and I always tell people when we think of the jet streams, that's what you're looking at right here with the variability of it. Typically, as the jet stream lifts, we'll say north, as it goes up, that's normally when we have warmer conditions. But if it dips south, that dips the temperature. So rise in the jet stream, rise in temperatures, dip in the jet stream, dip in temperatures. So if you're under that ridge or that rise in the jet stream, typically you're going to be warmer. If you're closer to where that dip is, you're going to be a little bit cooler. But again, it's all about the location of that jet stream because it will have an impact. Now, for the most part, as we've been alluding to, most of the lower 48 probably going to be a little more dry or a little warmer than average with some variability. Because remember, these are seasonal outlooks for months at a time. So the whole season is likely going to end up a little drier and a little warmer than average. But as Ross already alluded to, that doesn't mean we're not going to get some very cold days or some very snowy days. It just means when the season is all said and done, more than likely it's going to average out being a little drier and a little warmer.
I mean, if I could get an amen, I would say amen to that because she's just preaching over there. It's absolutely perfect.
I feel like I have to explain this all the time. And it's not like a soapbox thing. It's not a Rachel's rant. It is just it can be a little confusing, right? You know, and like you said, we think about warmer than average. Oh my gosh, it's going to be 80 degrees in winter.
Right.
It might just be 60 degrees in winter. We might just be 5 degrees warmer than average.
And 5 degrees would be substantial when you're talking about actual statistics. Like 5 degrees is
I meant like
way up there.
From an afternoon high temperature.
Yeah, no,
like
I get
60
you were
instead
saying
of
like
55,
a daily thing, but
yes,
I'm saying
not,
like seasonally. Yeah,
yes.
5 degrees would be like, whoa, we were torched.
You are correct. But it is, you know, it can be very confusing because our minds just typically go to one place, and it's literally our job as communicators of weather and of climate information to break it down to make it a little more understandable because we get it. It can be a lot to digest.
Exactly. These are hard concepts, and these are even hard concepts for us who have studied weather, have experienced it,
Sometimes
know how to
I
talk
still
about
have to look things up. I'm like, wait, how does it impact this? And I'm like, oh, that's right. Yeah.
Yeah, exactly. And when we come back, we're going to talk about what this means specifically for our area, and maybe if you have a kiddo watching this, potentially how many days of school could be canceled because of snowfall. We'll talk about that when we return.
On the radar with the CBS 17 Storm Team.
And welcome back. We left you talking about La Nina. We had a little bit of Ross's rants to start off the show. We ended with a little Rachel rant as well. And we're going to go into a topic that gets me pretty fired up.
Oh, here we go.
We're going to go back into a Ross rant. That's probably how we're going to end the show. But first, we are going to talk about what this specific winter setup does and how that actually impacts us here in Raleigh, North Carolina, in the Triangle, Central North Carolina area. And you may be surprised by this. At least I was surprised by this because you're thinking about, look, you see the jet stream here. You see how the moisture plays out. And you think, okay, well, there's going to be variability between when we have El Nino, when we have La Nina, and when we have a neutral season. But is that really the case? Well, first, we have to look at our actual averages. An all-time average 136-year record comes out to be about 7 inches. Now, over the last 50 years, it's been less than that. You can thank variability for that or a warming climate as well. And over the last 10 years, that's probably represented even better at 4.1 inches over the last 10-year average. And that could just be we're going through a period of less snowfall over the last 10 years. We just haven't had a whole lot. We haven't had a big storm like, say, back in 2000. And so this average can kind of be disrupted with a big storm or something like that. Because obviously we can get 6 inches out of a single snowstorm.
Oh, yeah.
But how does that actually impact it when we have El Nino, La Nina, and our neutral years? Rachel?
I mean, it's really not that much of a change. And again, sometimes it's hard for us to fathom. We think of La Nina, we just talked about. It typically means warmer for us with some variability. El Nino tends to make us a little bit wetter with, again, some variability in temperature. So you would think that because there's change that we'd have dramatic swings from El Nino to La Nina winters, and that's just not really the case. Now, technically, El Nino years on average bring us just under 7 inches of snow, La Nina closer to 6 inches, but then we also have a neutral phase, which will bring us about 6.5. But if you look at a La Nina, where it's just about 6 inches, to El Nino, which is almost 7, that's really less than an inch of snow in variability. All things considered, that's not a
1/10 of an
difference.
inch of precip. So yeah,
it's not a big difference at all.
Basically no difference there.
Yeah.
Which is surprising because, like you said, I would think you'd see variability with that, especially the variability with the jet stream. But it kind of makes sense when you think about where the jet stream dips and how that goes and where we are located. And all it takes really for us to hit our average snowfall is one storm.
Just one,
Just one storm riding along the coast with cold air present, and voila, we're talking about 4, 5, 6 inches of snow across the area. And there you go, near the average. Then you get another, little half an inch or dusting here or there, and boom, you've hit your averages. So
and that's what I was going to say too, is obviously this is going to vary for greatly for places in different parts of the country. But for us, sort of in this mid-Atlantic, southeast United States area, and we just showed you that map with where the jet stream ends up, it does kind of make sense that we don't have a lot of variability, or as much as we would think, from one ENSO phase to the next to neutral.
So you can see me rubbing my hands here.
Yes, here we go. Do you have your water and your coffee?
We're getting warmed up here.
Get ready, everybody.
We're going to talk about.
Sit back. I'm just gonna.
Yeah, we're going to talk about the polar vortex for a second. So I left the hurricane.
It's the hot trigger word every single winter.
Yes, it is. And I left the hurricane graphic as a background here intentionally because what I wanted to show was that we have cyclonic spin above the pole. So what we're talking about is the spin is a low pressure system. That's where the term vortex comes from, is that we're talking about a low pressure system that is always centered over the pole. It is in the stratosphere. Say it with me at home. Stratosphere. Okay, that is 31 miles above the surface. 31 miles above the surface. That's nowhere close to where we are experiencing winter or weather. We experience weather in the troposphere. That is what is down at the surface. It only extends to about 1.5 miles up. So, yeah, this is way above our heads. So next time you hear media, and yes, we are to blame because mainstream media loves to throw out polar vortex and they love to bring out these buzzwords. So we are partially to blame because we bring this into the nomenclature, and it is technically correct. But it is way above our heads. It is not at the surface. Okay, now I'm done on my soapbox.
I was gonna say, can you hop off your soapbox?
Yeah, we jumped off the soapbox. There are 2 phases that we typically see, and they usually affect how our winter weather and winter goes. A strong polar vortex is very centered to the pole, which you're getting ready to see, and a weak polar vortex, that happens whenever we have stratospheric warming or we have some kind of disruption in the flow, which means it's not very circular at the pole, and that allows lobes of the polar vortex to break off and bring extreme cold to portions like the lower 48. So when we say, or when you hear mainstream media talking about the polar vortex is visiting the lower 48, while technically that is incorrect because it's not happening at the surface, technically, at least meteorologically, portions of the polar vortex are influencing that cold.
And I think that's the key word there is it influences
Yes.
who experiences the cold and how far south the cold goes. And by the way, we were talking about the troposphere. Just want to shout out, don't know if we have any kids who have been to any of our school talks, but I always start out, at least with some of the older kids, talking about the levels of the atmosphere and talking about the troposphere and how that is where weather happens. So if any of y'all are watching, see? This is what I'm talking about. Troposphere. It's where the weather happens. Anyway.
That's why it matters.
It's why it matters.
That's why it matters. So I'm going to go back here because I want you to see at the very beginning of this graphic.
Sorry.
No, you're good. This is what a strong polar vortex looks like. Very circular right around the pole. A weaker polar vortex typically happens whenever we have warming air happening in the stratosphere. It can happen here like what we're showing over Greenland. More typically, it happens over Alaska or Siberia or portions of Russia, and that kind of breaks down the flow overall. And what ends up happening is the polar vortex can even split, where you get two central areas of low pressure system, again, in the stratosphere, so way up above our heads. When this happens, it allows the polar jet to deviate. Now, the polar jet is actually driven at the surface. It is driven in the mid to upper levels above our head, so above the troposphere, and it's very, very strong winds, and that allows colder air to dive south, especially whenever we have a setup like this, where we get that big dip in the jet stream to basically point north-south across the poles. We call that cross-polar flow. So that is something that is kind of buzzwordy as well. But usually whenever we get that type of setup, we drive some intense cold air down into the lower 48. You also have to keep in mind that if it is cold here, it is warm somewhere else. So usually when we are really, really cold, Alaska is actually really, really warm because there is displacement of that cold where it should be. It's no longer there. So usually you see, well, our low was, 17 degrees and Juneau, Alaska's low was 31.
Everyone loves to talk about the comparison. Oh my gosh, it's so warm in Alaska. Again, variability in the jet stream. If the jet stream is higher in one place, it has to be lower somewhere else.
Yeah, that's exactly right. And that's exactly what we see here. And if you're wondering, well, how often do we get these types of disruptions and we get these big breaks in the jet stream to dive in that colder air? Well, it typically happens about once or twice a winter. Coincidentally enough, as we are filming this on the 20th of November, there is actually a sudden stratospheric warming event getting ready to happen in the poles. It's already starting to see the signs of it. Warming is happening in the stratosphere, which means we are breaking down the polar jet as we speak, which possibly means that several weeks down the road, because again, this is happening way above our heads, eventually we're going to see that translate down to the surface where we're going to get stronger high pressures to develop probably around Alaska or in the Pacific Northwest. Think La Nina and the overall jet stream pattern there, which will likely drive cold air into the lower 48. Does that mean we're going to have winter storms in December? Don't know, because then we got to time up moisture and all of that as well. But it does look likely that we are going to have several bouts of cold. The first one probably unrelated to the warming event that's going on up there, but it looks like the first bout of colder air that's coming is going to happen shortly after Thanksgiving. So it's already on the forecast.
It's already on the way. But also it's important to remember that cold air is very often dry air. So as Ross was mentioning, if you get a blast of cold Arctic or even just downright cold air, that doesn't necessarily mean we're getting snow or freezing rain or any sort of winter weather like that. It just means it's going to be cold. We also have to have some other factors coming in with a transport of moisture coming in either from the Gulf or the Atlantic or somewhere else to really aid in any sort of winter weather development. Just like everything, it has to be a perfect setup in us for it to get anything in. Cold is cold, but cold does not always equal snow.
That's right. To get that perfect pastry, you've got to have all the ingredients together and get the baking
You
just
have
right.
been watching a lot of baking.
Way too much holiday cooking.
Oh
Way
my
too
gosh.
much holiday cooking. And on that note, we are going to wrap it up. If you have any questions, anything like that, make sure to email us at weather@cbs17.com, and you can get those questions to us. Maybe it'll even be a topic that we discuss on The Radar. So I hope you enjoyed another wonderful episode of On The Radar here with Ross and with
Rachel.
That's right. We'll see you next week.